Hello viewers, today we'll solve logarithmic equations. So we have question number 1, which is saying solve the following equations. We have part 1. So part 1 we have log of x equals to 2. So we are solving for the value of x. So remember that whenever the base is not indicated, meaning that the base for that logarithmic equation it is a 10. So for this our function we have log of x base 10. This is equal to what? 2. So this is a single logarithmic equation that we have. So whenever you have a single logarithmic equation, you change it to an exponential function. So the way we change this function to an exponential is we always say the base, okay, to the power answer equals to x. So what I'm saying is you're saying the base, which is a 10, that is to the power 2 equals to x. Then 10 to the power 2, we have 100. This will give us an x. So therefore the value of x is equal to what? 100. That's what we have for part 1. Then moving to part 2, we have log of 3x minus 5. This is equal to a 2. So we are solving for x as well. So if the base is not indicated, we know the base is 10. So we have log of 3x minus 5 base 10. This is equal to a 2. So since we have a single logarithmic function, we'll go ahead and change this one to an exponential function. So we have 10 to the power 2. This is equal to whatever we have inside the brackets. So we have 3x minus a 5 there. So 10 to the power 2, we have 100, which is equal to 3x minus a 5 there. So remember we're solving for the value of x. So we have 100, then that negative 5 will cross an equal sign so that it is now positive. Then this is equal to 3x. Then 100 plus a 5, we have 105. This is equal to 3x. So since we are solving for x, we have 3x, which is equal to 105. That's what we have. Then now we're going to divide throughout by 3, so that we have x now, which is equal to, remember for this type of mathematics that we are solving, we don't use a calculator, so it's a paper one kind of. So 3 into 3, we have a 1. 3 into 10, we have a 3, remainder 1. So we have now 3 into 15, we have a 5. So therefore the value of x will be equal to a 5. That's what we have. Then we have part 3. So part 3, what we have is log of 81 base x. This is equal to a 2. So we are solving for x, remember. So since we already have a single logarithmic equation, we are going to change this one to an exponential function. So it will be x to the power 2. This is equal to 81. So now since we have x squared equals to 81, and here you can see that the base here is the variable, so meaning that we have to make the powers to be the same. So we have x squared, which is equal to 81 can be written as 9 to the power 2. So we can see that x is equal to 9. That's what we have. Then moving to part 3, moving to part 4, we have log of open brackets, then the modulus of x plus 1. The modulus of x plus 1, this is equal to a 3. So how do we solve for the value of x of this our function that we have? So for us to solve for the value of x, what we're going to do is we'll go ahead and change this one to an exponential function, because the base there it is a 2. So we're going to say 2 to the power 3. This is equal to open brackets, then you say x plus a 1. So I'll first maintain the modulus symbol. So we say 2 to the power 3 is equal to the modulus of x plus 1. Then 2 to the power 3, that's an 8, which will be equal to, so we remove the modulus, meaning that we have plus or minus, open brackets, then we have x plus a 1. So now we have 8, which is equal to positive times what? X plus a 1. Or we have 8, which is equal to negative, open brackets, we have x plus a 1. So meaning that this would tell us to say we're going to find the values, two values of x. So now we have 8, which is equal to positive times x, we have an x. Then positive times 1, we have a 1 positive. Then we have 8. Then that one will cross an equal sign, so it will be negative 1. This will be x. So 8 minus 1, we have a 7, which is equal to x. So therefore, one value of x will be equal to what? 7. Then on this other side, we do the same. We have 8 equal to negative times x. It will be negative x. Then negative times positive 1, it will be negative 1 there. So we have 8. Then this negative 1 will cross an equal sign, so it will be positive 1. This will be equal to negative x. So 8 plus 9, that's 8 plus 1, that's a 9. This will be equal to negative x. So we can see that now we have negative x, which is equal to a 9. So we're going to divide by negative 1, negative 1. Then we have the value of x, which is equal to a negative 9. So therefore, we have x equal to 7 and x equals to negative 9. So that one becomes the answer for part 4. Then now moving to part 5. So for part 5, what we have is we have log of the base of, so the base is 2. Then here we have 5x minus a 4 plus, it's not plus, so equals to 1 plus log of 2x plus a 6. The base is a 2. This is what we have. So we're solving for x. So what we're going to do first is we'll make the other log to cross an equal sign. So we'll make this log to cross an equal sign, so it will be negative. So we have log of the base of a 2. Then here we have 5x minus a 4. Then minus log of 2x plus a 6. The base is 2. This is equal to a 1. That's what we have. Now we're going to apply laws of logarithmic equations. So we have the properties. So we know that if the bases are the same and here we are subtracting, then you divide whatever you have inside the brackets. That's one of the property. So we're going to say we have log, the base is 2, then open brackets, we have 5x minus 4, then over 2x plus a 6. That's what we have. Then this is equal to a 1. So now we can see that now we have a single logarithmic function. So we'll go ahead and change this one to an exponential function. So we have 2 to the power 1. This is equal to 5x minus what? 4 over 2x plus a 6. That's what we have. So we know that 2 to the power 1, we have 2. This will be 5x minus 4 over 2x plus 6. Then we divide by 1. So do cross multiplication, we have 2 times 2x plus 6. This is equal to 5x minus 4, because we're multiplying that with a 1. So now we just have to simplify this one now further and solve for the value of x. So we'll multiply 2 with whatever we have inside the brackets. So we have 4x plus a 12. This will be equal to a 5x minus a 4. Then 4x. Then we'll collect our like terms. So positive 5x will cross an equal sign. So we'll bring it to this side. So it will be a negative. Then this will be equal to negative 4 minus a 12. That positive 12 will cross an equal sign. So therefore it will be negative. Then 4x minus 5x, this is negative x, which is equal to negative 4 minus 12, this is negative 16. Then here we have negative x, which is equal to negative 16. So we're going to divide by negative 1 on both sides. Then we have the value of x, which is the positive 16. So that one becomes the value of x for that question. So now we move to part 6. So part 6 is saying that so we have now part 6. So we have log of open brackets x plus 1 plus log of the base is a 2. Even there the base is a 2. Then open brackets we have x minus a 2. Then this will give us a 2. So since we have 2 logs there, so we need to combine this so that we have a single log. So we'll still apply the same properties for logs. Since the bases are the same, and here we are adding, so meaning that we'll multiply whatever we have inside the brackets. That's the second property that you need to know. So meaning that we have log over the base 2, then x plus 1. We are multiplying this with x minus 2. Then this will give us a 2. So first, before we change this one to an exponential function, we'll simplify it by multiplying first. So we have log over 2, open brackets, so we'll start multiplying. So x times x, we have x squared. Then x times negative 2, we have negative 2x. Then positive 1 times x to be positive x. Then 1 times negative 2, we have a negative 2. This is equal to a 2. We have log over the base of 2 there. The base is a 2. Then here we have x squared. Then negative 2x plus 1, that would be negative x minus a 2. Then this is equal to a 2. So now we can go ahead and change this one to an exponential function. So it will be 2 to the power 2. This will be equal to x squared minus x minus a 2. That's what we have. So we just have to simplify this and solve for the value of x. So 2 to the power 2, we have a 4. This will be equal to x squared minus x minus a 2. Then now I'll start with x squared minus x minus 2. This is equal to a 4. So we have x squared minus x minus 2. Then that positive 4 will cross an equal sign, so it will be negative 4. Then this will be equal to a 0. So now we have x squared minus x minus negative 2 minus 4, it will be negative 6. Then this will be equal to a 0. So remember, we're solving for the values of x and we have a quadratic equation. So we'll look for the product, sum, and factors. So the product will be 1 times negative 6, so it is negative 6. Then the sum is negative 1. Then the factors, you are looking for two numbers, you add them, should be able to get a negative 1. You multiply them, you get a negative 6. So we have negative 3 and what? Positive 2. So these are the two numbers that we use as the factors. So here we have x squared minus 3x plus 2x minus 6. This will give us a 0. That's what we have. Then from here, between these two numbers, we'll factor out what is common. So x is common. So now we have x minus 3 here. Then here we'll multiply, we'll factor out the positive and the 2, which is common. So we have x minus 3. This is equal to a 0. So now we have x minus 3 and x plus a 2. This will be equal to a 0. So now from this point now, we have x minus 3, we'll set this to 0. Or we have now x plus 2, we'll set this to 0. So we have the value of x, which is equal to positive 3. Then here the value of x, which is equal to negative 2. That's what we have. So now we need to confirm, because whenever you get a negative value, whenever you're solving logs, you test. So we can see that when we put a negative 2 here, what is x to be negative 2 plus 1, it will be negative. So what I'm saying is we are testing. So we have log over the base 2. Here we're putting negative 2 plus what? A 1. Okay, plus here the log of that is where there's x, we're putting a 2, we're putting a negative 2, then e minus what, 2, this is equal to 2. So here we can see that we're going to have log, the base is 2, open, then when we say negative 2 plus 1 is a negative 1, so plus, even from here you can conclude to say whenever you have log of a negative, that's undefined. So here we're going to have one value of x. So we're going to conclude and say that at x equal to negative 2, this our function will be undefined because we have tested there. So that's what you do. Then now moving to part 7, we are solving this logarithmic equation. So part 7, we are solving this logarithmic equation. So we have that is log of the base 3, then we have an x minus 2 log of the base x, then here we have a 3 which is equal to a 1. So this is what we are solving. So the first thing, you look at the bases. We have the base 3 here, the base here, it is x. So here we can't apply that property because the bases are not the same. So what we're going to do first is we're going to change this part so that it has a base of 3. So we change this base x to base 3. That's what we're going to do. So to change that, we're going to say we maintain, we have log of the base is 3, here you have an x minus 2. So we're going to multiply this by log, that is over log. So the base is 3, even here the base is 3. Then now this 3 will be on top there, then the x from there, it will be right here. That's what we're going to have. Then this will be equal to a 1. So now we have a log of the bases 3, then here have an x minus, we have 2, then applying the property now, log of 3 base 3, it is 1, that's the property, so it is a 1. Then we're going to say over, we have log of x base 3, this is equal to a 1, that's what we have. So now we have log of the base is 3 there, that's what we have. Then this is x, then minus 2 times 1, that's a 2 over, then we have log over x base 3, this is equal to a 1, that's what we have. So what we are going to do, since we have a log over x base 3, even here we have a log of x base 3, we are going to use substitution method. So what we're going to do is we're going to let log of x base 3 to be any variable, so we use a y, meaning that where there is log over x base 3, we'll put a y, so meaning that we have y minus a 2 over a y, then this will be equal to what? A 1. So now we have a y, that is minus 2 over y, this is equal to a 1. So here we divide by a 1, so the common denominator will be a y. So say 1 into y, have y times y, this is y squared, minus y into y, you have y 1 times 2, so this is equal to 1 there. So now we'll do cross multiplication here, so we have y squared minus 2, which is equal to y. So we have y squared, we are arranging this one to a standard quadratic equation. So we have negative y when it crosses an equal sign, then minus 2, this is equal to a 0. So first we're going to solve for the values of y. So here we'll find the product, sum, and factors, because we have a quadratic equation. So the product will be negative 2, the sum negative 1. So the factors will be negative 2 and positive 1 there. So I have y squared minus 2y plus that is y minus a 2. This is equal to a 0. So that's what we have. So now between these two, we factor out what is common. So we have y open, then we have y minus 2 close, then we factor out a positive here, that is a positive 1, then we have a y minus a 2, this is equal to a 0. So now we write the products. We have y minus 2, and we also have y plus a 1, this is equal to a 0. That's what we have. So now we just have to simplify this further. So we have y minus 2, set it to 0, and also y plus a 1 will set it to a 0. So here we have y which is equal to a 2, then this side you have y which is equal to a negative 1 there. So now since we have to let a log of x base 3 to y, we are going to recall, okay, we'll recall that we said log of that is x base 3 to be equal to y. So we require and substitute because you're not solving for y but we're solving for x there. So now this now will be, since we have the value of y which is equal to 2, so we'll say we have log of what, x base 3. What is y? We'll put it 2. So now we'll change this to an exponential. So we have 3 to the power 2 which is equal to x, and you can see that the value of x will be a 9. Then for y equals to negative 1, we'll do the same. We have that is log of x base 3. This is equal to what? A negative 1. So we'll change this to an exponential to be 3 to the power negative 1, which is equal to x. Then you can see that x will be equal to 1 over what? 3. So those are the two values of x. Then now we move to part 8. So part 8, what we have is we have log of x, that is base 2. This will be equal to log of 27 base 8. That's what we have. So how do we solve for the values, for the value of x here? So as you can see, the bases are not the same. For the first one, you have a base 2. Then for this other one, the base is an 8. So we can change this base 8 to base 2 using the same method that we've used on the previous question. So now we have log of x base 2. This will be equal to what? I will say log. We're changing this to base 2. Then over what? Log the base is 2. That's how we are doing it. Then here we have a 27. Then this side we have an 8. This is what we have. Then now it is now from this point where we say we have log of x, then the base is 2. So this one now will give us we have log of 2, then this is a 27, then over, I'm going to say over, then this is log of 2, then 8 can be written as 2 to the power 3. Okay, so now here we have a log of the base 2. Here you have an x. This will be equal to log of 27. The base is 2. Then here we are going to divide by, we can drop a 3 there. That will be log of 2 base 2. That's what we have. Then now this will give us, we have log of 2, then this is x, then this will be equal to what? So it will be log of 2, then here you have a 27. So that's what we have. Then now it will be equal to the property there, it will be what? It will be a 3 there. So the property will be a 3. So that's what we have. So here we have a 3. We'll multiply this with log of 2 base 2. That's a 1. That's what we have. But I've just noticed one thing on this question. I've noticed one thing on this question. The base was supposed to be a 3. Okay, so the base for this question was supposed to be a 3. Okay, but anyway, since this is how it is, it's okay, we'll solve it. So we have log of x, that is base 2, then this will be equal to that is log of 27, then the base is 2 over what? A 3. So we'll do cross multiplication, meaning that we have 3. That is log of 2, log of x base 2. This will be equal to, that will be log of 2. Then here we have a 27. So now from this point, we're going to raise 33. So now it will be log over 2, then x to the power 3. This will be equal to what? Log over 2, then you have a 27. So now since the bases are the same, we have an equal sign. you're going to say x to the power 3 should be equal to a 27 there. Okay, so that's okay. Then now we have now x to the power 3. This will be equal to a 27. Then we are going to introduce a cube root. Even here we introduce a cube root, and we can see that the value of x will be equal to what? A 3. So that's how you solve for x. Then now moving to question number 2, which is our last question. So the question is saying solve the following simultaneous equations. Solve the following simultaneous equations. So for A, we have that is 2 to the power y, which is equal to 4 to the power x. Then also we have 2, then log of y. This is equal to log of 2 plus what? That is the log of x. This is what we have. So now this is a simultaneous equation, so meaning that we are going to form two equations. So for the first part, we have an exponential function, so this can be written as 2 to the power y. This will be equal to 4, can be written as 2 to the power 2. Then remember there is what? An x, so it will be 2x there. So you can see that y will be equal to what? 2x. This becomes our first equation. Then we move to this, our second one. So do the same. So now since we have that is 2 log of y, this will be equal to what? So now we can see that here the bases are the same. Remember the base is 10 if the base is not indicated. And here we are adding, meaning that we multiply 2 times what? X. So now this will be log of what? 2x. Okay, then now we'll raise that 2, so that can be written as log of y, then to the power 2. This is equal to what? 2x, log of 2x. So this is equal to log of what? 2x. That's what we have. Now from this point now, we are going to say, since the bases are the same, we have an equal sign, so we just have y squared, which is equal to what? 2x. This becomes our second equation. So now we are going to we'll solve our first equation and our second equation. So we have y, which is equal to 2x, and we have y squared, which is equal to what? 2x there. So that's what we have. So now from this, now since we are solving for the value of x, what we just do is we use substitution method. So we'll pick this one, we'll say y should be equal to 2x. So meaning that since this is our second equation, the one with y squared equal to 2x, meaning that where there is y, we substitute with what? A 2x. So I have a 2x, then here we have a 2, this is equal to 2x. Then 2 to the power 2, that's a 4, then x is squared, then this is equal to 2x. So now we have 4x squared, then 2x will cross an equal sign, so it will be negative 2x. That's what we have. Then now this is equal to 0. So from here now we'll factor out what is common. We can see that 2x is common. Then here we'll remain with a 2x minus 1. Then this will be equal to 0. So now we have 2x, which is equal to 0, or we have 2x minus 1, which is equal to a 0. So now we have 2x, which is equal to 0. You divide by 2, divide by 2, then the value of x will be 0. Then here we have 2x, then negative 1 will cross an equal sign, so to be positive 1. So we have 2x, which is equal to 1. So we divide by 2, divide by 2 throughout. Then we have the value of x, which is 1 over a 2. So that's how we solve that our equation. So for today, we can end here. Thank you so much for your time.